Come in over here.
All right, y'all. So this is looking at 8.1 support. And the reason I want to do this is to give y'all a few definitions. So the first thing we're going to look at polynomials. In a polynomial is an expression made up of one or more terms. Okay, so it's made up of one or more terms. So we're going to look at the classifications of these polynomials first. And there's 5 we're going to look at in here. We're going to look at linear. Whoops, let me start that over. We're going to look at constant. So a constant polynomial has no variables. So that'd be something like f of x equals a number like 4. Notice there's no variables with this and a constant polynomial. Okay, next we look at linear. So a linear polynomial makes a straight line. So a linear polynomial will be something like 3x minus 2. It does have a variable in it, and y'all, the exponent on that variable, if it's not shown, is the 1. And that'll come into play in a little bit, okay? Next polynomial, quadratic. And we've been playing with quadratic graphs, which look like the parabolas or the U-shapes. And we've been playing with the quadratic formula. And remember, the quadratic formula solves x squared type equations, okay? So we could have something like 5x squared plus 2x minus 3. So quadratic, the variable has an exponent of a 2. Next is cubic. Cubic would be something with a exponent of 3 on the variable. So how about something like x to the third minus 8. So cubic has an exponent of 3. And then finally, we got quartic. Quartic expressions have an exponent of 4. So we could have something like x to the 4th plus 3x squared minus 7. Now I'm going to get into a little bit more of these after I give you a few more definitions. First, we'll look at the leading term. The leading term of a polynomial so the leading term of a polynomial is the term that contains the highest exponent. So if I was looking at my examples, the leading term of a constant polynomial would be the 4, which is the only term. Of the linear, the leading term of this polynomial would be the 3x to the first. It is the term that has the highest exponent. For my quadratic here, the leading term would be the 5x squared term. Once again, it has the highest exponent. On the cubic, my leading term is the x to the third. And then y'all finally on this quartic one, the leading term would be the x to the 4th. So it's the whole term that contained the highest exponent. So the leading coefficient well, y'all, the leading coefficient is the number in front of the leading term. All right, so the coefficient on the constant one would be the 4. The 4 is everything on a constant polynomial. For my linear one, the leading coefficient would be the 3 because it's the number in front of the leading term, which was the 3x. For my quadratic here, my leading term was 5x squared, so that makes the leading coefficient 5. But y'all here, my leading term is the x to the third term on this cubic. There's no number in front of that x. So that means the leading term, if there's not a number there, is a 1. And then the same thing with this quartic. Since it don't have a number in front of that x4, we treat that like a 1 in front of it, okay? So the leading coefficient is just a number in front of my leading terms. Then we look at the degree. The degree is the highest exponent of the polynomial. So over here, I'm going to write the degree of each of my 5 polynomials. On a constant polynomial, since there's no variable there, that would have a degree of 0. For the linear, there wasn't an exponent there, so we put a 1 there, which means the degree is a 1 for a linear. Quadratic, highest exponent is 2, so that degree is a 2. Cubic, highest exponent is a 3, so that degree is a 3. And then y'all finally on my quartic, highest exponent is a 4, so it has a degree 4. So I'm about to play with some examples on MathLab using this, and they're going to ask us to classify them, and then the leading term, leading coefficient, and the degrees, okay? So y'all, I'm going to switch us over to MathLab. All right, so they're giving me a polynomial, negative 4x squared minus 8. So the first thing we got to do is classify that polynomial as a constant, linear, quadratic, cubic, or quartic. So if you notice, the leading term is the negative 4x squared term. It's got an exponent of 2. And we said if the exponent of 2 was the highest exponent, that was going to be quadratic. So you would click the quadratic, check that answer. Then it wants to know what is the leading term. Well, they're breaking the 2 terms out as a negative 4x squared and a negative 8. Well, the leading term contains the highest exponent, so that'll be the negative 4x squared term. All right, y'all, then they're going to want to know the leading coefficient. Remember, the leading coefficient is the number, so the number on my leading term is a negative 4. So we put in the coefficient. And then it wants to know the degree. Well, remember, the degree is equal to the highest exponent. So since my highest exponent was a 2, my degree is a 2. All right, y'all. So the leading term of the polynomial. Be careful on this one. It's out of order. But my leading term has the highest exponent, which is that x to the 4 term. So I would put in my x and then my exponent of 4 and check that answer. The leading coefficient. So y'all, remember, there's not a number in front of that x to the 4th. So my leading coefficient is a 1. The degree is the highest exponent. And that's also going to be with your leading term, because that's how we pick the leading term. So the degree of this one is the exponent of 4. So I got a degree 4 polynomial. So then the polynomial is quartic, quadratic, cubic, constant, or linear. And we said if it had an exponent of 4 as its degree, that would be quartic. And then we would check our answer. So y'all, this next one's on y'all. So they want to know, what is the leading term of this polynomial?
-1/6 squared.
So that's going to be -1 divided by 6. And then you said x squared. So good job. You got to have all that. Good job. So what is my leading coefficient?
X squared.
Well, remember, on the leading coefficient, I just want that number. So what's my number?
-1/6.
So -1/6. So then y'all would check that. The degree of this polynomial is, so basically the highest exponent is what?
2.
Right, y'all put in your 2. So is that polynomial cubic, constant, quadratic, quartic, or linear?
Quadratic.
Quadratic. All right, y'all, you would put that in, check that answer. All right, y'all. So the leading term of my polynomial that I'm showing, -1/4 x to the 3rd minus 4x plus 6. And this one's actually
-1/4x cubed.
so -1 divided by 4, and then x cubed. All right, so it's the whole term when you're looking at the leading term. So now they want the leading coefficient.
-1/4.
The degree of the polynomial.
3.
I think it's just me and you today, ain't it? All righty, y'all. Classify that polynomial as cubic, quartic, constant, quadratic, or linear.
Cubic.
Cubic. There you go. Okay, so I skipped 1 and 2, it looked like. So let me go back to 1. All righty. Leading term of the polynomial would be the -1 divided by 3. What is that? X to the 3rd. So you just got to watch whether they're in order or not, because it ain't always the first term. Sometimes they're out of order. So my leading coefficient of this one is going to be that number, which is what, a -1/3. The degree of this polynomial is 3, because that's my highest exponent. And then y'all, since that had a degree 3 exponent, this would be cubic. Right, so the last one we didn't do. Is this polynomial constant, linear, quadratic, cubic, or quartic?
Quadratic.
So quadratic, exponent of 2. All right, the leading term of that polynomial?
A.
Okay, so that'd be my negative 2x squared. The leading coefficient,
-2.
and then finally they're going to ask us for our degree. Whoops. So the degree of this polynomial
2.
is a 2. So y'all, that's the support. It only has those 6 questions going over the classifications and lead coefficients and lead terms and all that fun stuff. Okay. So now we're going to get into the college algebra portion of the day. So today we're looking at 8.1, and it deals with polynomial functions. So we're going to start with talking about the end behavior of a graph. And y'all, when I talk about the end behavior of graphs, I'm talking what's happening to the graphs as we head toward the negative infinity direction and positive infinity directions. So polynomials all have a similar pattern of what's happening to the ends of the graphs as we head towards those infinities. So we're going to look at a chart here. This is going to be our end behavior chart. So to be the end behavior chart, we look at the degree. So we're going to compare the degree of the polynomials. Now the degree can be positive or the degree can be negative. So we look at the degrees, and then we're going to look at the lead coefficient. So the lead coefficient. Whoops, I'm backwards here. So yeah, on my degrees, they can be even or odd. So fix that, even or odd degrees. The lead coefficients can be either positive or negative. So that's going to give us a little chart here with 4 options. Okay, so make sure you make the degree even and odd. I must have been having a brain lapse there. The lead coefficients, positive or negative. So if my polynomial has an even degree, so if the highest exponent is an even number and the lead coefficient is positive, in the long run, both ends of that polynomial will go uphill. So like the x squared graphs. X squared graphs made a nice shape U. X4 graphs will do the same thing, but they might have more turns in the middle. X6 graphs, same things, but they might have a lot more turns in the middle. So that's why they're not connecting the middle, because based on how big your even exponent is, there might be a lot of turns in here. Now, if the lead coefficient's negative and you got an even degree, then remember when we put a negative in front, that flips the graph over the x-axis. So if you got an even degree and the lead coefficients are negative, both ends in the long run will go downhill. So then we look at the odd ones. Now remember, these even ones, they're symmetric, right? Now look at the odd. If it's an odd degree and it's got a positive lead coefficient, they're going to tend to go uphill, left to right. So that'd be almost like the graphs that were symmetric to the origin, remember? Now, that's if it's positive and odd. If it's negative and odd, it's going to flip it and it's going to go downhill from the left to the right. So y'all, these are the 4 shapes that can happen to a polynomial. Okay. So now on our exercises. So save this chart because you're going to definitely need these, okay? So on this exercises, they want us to select one of the sketches. That describes the end behavior. Of the function. Now for these exercises, I'm going to call this A, B, C, and D. That way we can pick A, B, C, or D for these, okay? So for number 1, they're giving us this. F of X equals square root of 2 x to the third plus 4x squared minus 4x plus 2. So the 2 things I need to know out of this function here is the degree even or odd, and is the lead coefficient positive or negative. So y'all, let me start with my degree. The degree of this polynomial is what?
Three.
So the degree is 3, and 3 is odd. So it's going to be either B or D at this point. The lead coefficient. Is that lead coefficient square root of 2? Is that positive or negative?
Positive.
Positive.
So definitely positive. So there's no negatives in front of that. So it's definitely positive. So if it has an odd degree and a positive lead coefficient, well, here we go. Odd, positive. That's going to be choice B, which is going to go uphill, left to right. So y'all, that's the trick on these, is just to figure out the degree, odd or even, lead coefficient, positive or negative. All right, y'all, same thing. P of X equals negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 1. So the first thing we want is the degree of this polynomial here. And see, they're trying to throw y'all curveballs by putting these radicals in here and this pi. All right, y'all, the highest exponent looks like a 6. So that means my degree is going to be 6. My lead coefficient is this negative pi. But I ain't worried about the pi. All I want is that sign. And if you notice, there's a negative in front of the pi, so the lead coefficient is negative. So watch what we got. We got an even degree, which is going to be A and C here, with a negative lead coefficient. So it tells me if it's negative and even, both ends will go down in the long run. Okay?
How is it negative?
Say again now.
How is the leading coefficient negative?
Well,
Oh, I see the negative in front of the.
because you got that little negative sitting up there.
Okay.
All righty, y'all. So let's play with some more of these. All right, so I'm gonna make my little chart real quick. So we had even and odd, and then positive and negative. So remember, even and positive both went up, even and negative both went down. Odd and positive went uphill, left to right. Odd and negative went downhill. All right, so number 3 says f of x equals negative 4.6 x to the 4th plus x to the 6th plus 0.2 x to the 7th. So what we want to look at is what is our degree first. Once we got the degree, we look at the lead coefficient. So y'all, the degree of this little function is what?
Seven.
Sound like you were saying 7.
Yes.
Okay. So the degree of the highest exponent 7, which means my lead coefficient. So be careful on this. This is where I get people. But the lead coefficient is the number in front of that leading term. So I need to know, is that 0.2 positive or negative? And that 0.2 is definitely positive here, okay? So be careful. They try to make you think that this negative 4.6 is your lead coefficient by putting it in front. But remember, the lead coefficient is the number in front of the leading term here. So you got an odd degree that's positive. So here's my odd degrees, positive. So it's going to be the top right. So it's going to go uphill, left to right. And y'all on these examples, so there's one more of those. They'll have A, B, C, D for your choices, okay? So one more of those, let's try f of x equals 5 plus 1/5 x to the 4th minus a 1/2 x to the 3rd. All right, so another one that looks like it's sort of out of order here. But I need the degree of this function. And then we'll look at the lead coefficient.
4.
So the degree is 4. So that makes the lead coefficient what?
Positive.
Positive, because it's a positive 1/5. Good job. So let's see. When it's an even degree and it's positive, it's going to be like the first picture. In both ends, we'll go uphill. Now, y'all, so they start out just wanting y'all to get used to the end behavior. Now, sometimes when you graph these, you can't tell. You got to zoom way out on those graphs so that you can see what's happening to the ends of them, okay? All righty. Now, this is almost going back to what we were doing earlier in class. They want us to use substitution to determine whether 2 is a 0 of the following. Now remember, zeros are the same as solutions. Okay? So if a number is a 0 of a polynomial, that means when you plug the number into the polynomial, it has to result in the answer of 0. So here's my polynomial. F of x equals x to the third minus 11x squared plus 16x plus 3. So they're giving me this polynomial, and they want to know is 2 a 0. So they want to know if 2 is a 0 of this polynomial. So y'all, what we would do, we're going to find what f of 2 equals. So that's what they mean by substitution. You're going to put a 2 in for all 3 of these x's. So that's going to give us 2 to the third minus 11 times 2 squared plus 16 times 2 plus 3. If this all equals 0, then that'll be yes, 2 is a 0. If I get any other answer, that's going to be no. Okay, so that's what it means to be a 0. When I plug it into the expression, my answer has to be 0, okay? So y'all, I'm going to start with these exponents first. 2 to the third power. 2 times 2 times 2. So it's going to give me 4 times 2, which is 8. I'm going to bring down to minus 11 and figure out what 2 squared is. Well, that's 2 times 2, which is 4. And then, y'all, I'm just bringing everything else down at the moment. All I did on that step was the 2 exponents. Now I'm going to go through and multiply wherever I need to. So the 8 is good. Right here, I got a negative 11 times 4, which will give me a negative 44. Here, I got a 16 times 2, which is 32. And then I got my plus 3. All right, y'all, let's see what we get. 8 minus 44 is a negative 36. Negative 36 plus 32 is a negative 4. Negative 4 plus 3 gives me a negative 1. So this is no, not a 0. Okay, so that's what you do. You're going to check it by plugging your number in and seeing if you end up with a 0 here, okay? All right, y'all, turning the page. And that was just a yes or no answer on that one. So if you get a 0 out of that, you're going to put yes, okay? So now, new definition. Multiplicity. The multiplicity is how many times a 0 occurs. So it is the number of times that a 0 occurs. Now, multiplicities are usually equal to exponents, okay? So let's play with a problem here and deal with some multiplicities. All righty, so let's play with this example. They say, find the zeros of the polynomial and state the multiplicity of each. All right, y'all. So for this one, they're giving us f of x equals x squared minus 4 to the 5th power. So to find the zeros, you're going to take the stuff inside the parentheses and set that equal to 0. This 5 out here, remember that 5 exponent out here is telling me I got 5 of these x squared minus 4s being multiplied together. So it means this really, right? X squared minus 4, x squared minus 4. So that's what that exponent 5 tells me. It's telling me I got 5 of these running across here, okay? So we like to use exponents for shorthand so we don't have to write all this out. Now, we don't have to solve every single one of these. I'm just going to solve this factor right here. So to find the zeros is the first thing we're going to do. And we're going to do that by taking that x squared minus 4. And to find the zeros means you're going to set it equal to 0. So y'all, we're going to solve this for the x's now. So the easiest way to solve it when you got an x squared term in a number is to move the number to the other side and do square roots. So I'm going to move the 4 over by adding. So y'all look, we get our x squared, that cancels. So I get x squared equals 4. Now to turn x squared into an x, I'm going to take square roots of both sides. So the square root of x squared is x. What is the square root of 4?
Two.
2
All right, but y'all remember I need 2 answers because I got an x squared here.
plus or minus 2.
Plus or minus 2. So you got to get into thinking now at this point. I definitely got to account for those negative 2's, okay? All right, so the zeros are going to be plus or minus 2. Each has a multiplicity of, well, y'all, if this factor gave me a plus or minus 2 from a zeros, how many times does that occur in this polynomial? Well, guess what? That's what that 5 is. It's telling me the multiplicity because this factor happens 5 times. So my zeros are plus or minus 2. Each of them has a multiplicity of 5. And that's all we do. Solve the factors for the zeros. And then these exponents on the outside of these parentheses are going to give us the multiplicities. All right, y'all. Watch this one. This one's a little trickier. I got f of x equals x to the 7th times x minus 2 squared times x plus 7. So when you got a single factor like this x, that exponent will be its multiplicity. Here I got binomial factors, which had 2 parts. So the exponent outside the parentheses will be the multiplicity for this one. Here I got an x plus 7. It does not have an exponent out here. So what exponent would be outside these parentheses?
1.
So we would treat that like a 1 there. So notice I got 3 factors. I'm going to set all 3 of my factors equal to 0. And y'all, anytime you got a single factor like this, x, it always equals 0. So one of the zeros is going to be 0 if you got a single x factor like this. Now the other 2, I'm going to set both of these equal to 0. All right, so this one's already solved because there's nothing to add or subtract. The second one, we're going to add 2. And again, x equals 2. The third one, I'm going to subtract 7 and get x equals a -7. So watch how they got these answers. The smallest 0 is blank with multiplicity blank. So y'all, I got a 0 for a 0, a 2 for a 0, and a -7 for a 0. So what is the smallest 0 that I have?
-7.
-7. And it has a multiplicity of what?
One.
So good job.
1.
So good job. All right. The middle 0 is blank with multiplicity blank. So y'all, what is my middle 0?
0.
Okay. So the 0 of 0, what is its multiplicity?
7.
So definitely a 7. And then they say, hey, the largest 0 is blank with multiplicity. Ooh, these big words of blank. So y'all, what is my largest 0?
2.
2, and it had a multiplicity of
2.
a 2. There you go. Remember, exponents are going to equal these multiplicities. The factors are going to give me my zeros, okay? All right, y'all, so let me try one more of those. All right, so moving my camera back up. All right, so number 8 is the same thing. F of x equals -4 times x minus 3 squared times x plus 4 to the 4th times x to the 3rd. Now, I've got my -4, but the -4 does not have a variable with it. So since the -4 does not have a variable with it, it's not going to give me a 0. So you could basically scratch out that -4 because it does not have a variable with it. So to find my zeros, I'm going to set my 3 variables equal to 0. I'm going to set x minus 3 equal to 0. I'm going to set x plus 4 equal to 0. And then remember that single x, I'm going to set it equal to 0. So once again, the single x is going to give me the 0 of 0. So y'all, let's figure out the other two. We're going to add 3 to the first one. X equals 3. All right, y'all, so hang on a second. I got to stop this share a second. I'm getting a lot of static back. All righty. All righty, so the first one gave me x equals +3. The second one, I'm going to subtract 4 from both sides. And I get x equals a -4. So here's how they do these answers. They say the 0, 3 has multiplicity blank. y'all looking at that, your 0, 3, what is its multiplicity?
2.
Exactly, because the parentheses that gave me the 0 of 3 had an exponent of 2, so good job. Blank is a 0 of multiplicity 4. So what are we putting here? Blank is a 0 of multiplicity 4.
-4.
Well, that'd be -4 because -4 came out of these parentheses and it had that exponent of 4. Then it says the remaining 0 is blank. It has a multiplicity blank. So what was my remaining 0?
Zero.
All right, so the remaining 0 is 0, and it had a multiplicity of what?
3.
Of 3. Okay, y'all, so that's a trick on those. You're only concerned with the factors that have the variables in them, okay? This -4 out front, that was like a constant term, and it has no variables, so there's no way to set a -4 equal to 0 on these, okay? All righty, so let me see. All right, so what I'm going to do, I'm going to stop my share for a second, and I'm going to pause this so we can take our break. So let me get my screen back. All right, so they still want us to find the zeros. And state the multiplicity of each. Now, the difference in this problem I'm about to do, these problems we just did, they already had them factored for us. But y'all, this next one, we got to factor it and then solve for our zeros, okay? So let me show you what we got going on. We got an f of x equals x to the third minus 4x squared minus a x plus 4. Actually, I'm gonna move my camera down a little. So to find the zeros, we got to take our expression and set it equal to 0. All right, y'all. So the trick is going to be getting this factored. When we have 4 terms like this, to factor this, I'm going to factor by grouping. So that's the method I'm going to use to factor this, y'all. So to factor by grouping, you set this into 2 groups of numbers. The first 2 terms go together and the last 2 terms go together. So first of all, you get your 2 groups. So from each of these groups, we're going to factor out the greatest common factor of each group. So I'm going to look at the first 2 terms. Now, the greatest common factor is the largest factor that they got in common. So for the first 2 terms here, I got an x to the third and a -4x squared. The greatest common factor of these first 2 terms would be the x squared. They both have at least an x squared in them. Now, these ones don't have a number in common because that's a 1 and that's a -4. So the only thing they got in common are a couple x's. This one has 3 x's. This one has 2 x's. So that makes the greatest common factor the x squared. Now, inside the parentheses, I put the remainders that I get when I divide both of these by that x squared. So y'all, if you had an x to the third and you factor out an x squared, that's going to leave you an x minus, and then we take the 4x squared and divide that by the x squared. Well, y'all, the x squareds would cancel on that one, and all that's left is the -4. So I factored out the greatest common factor of the first 2 terms. Now, when you factor out the second greatest common factor, the second greatest common factor will be whatever sign this third term is. So since that's a -x, the second greatest common factor will be a negative. And there's only one thing that an x plus 4 has in common. The only factor that these two have in common would be a 1. So the second group here, you at least have to factor out a 1, okay? So watch what happens. If you had a -x and you factored out a -1, that's going to make that a positive x. If you have a +4 and you factor out a -1, that's like 4 divided by -1. That's going to make that a -4. So remember, second GCF has the same sign as the third term, and you at least have to factor out a 1, okay? So notice these. At this point, the parentheses must match up. And all this is still equal to 0. So the parentheses must match at this point. So here's where you got to watch what's happening. Since both of these terms have an x minus 4 in them, we're going to factor out the x minus 4 into the first parentheses. So y'all, if you factored out that x minus 4 from both of these terms, what's left will be the x squared minus 1. So the x squared minus 1 goes into the second parentheses, and all this is equal to 0. So notice, the parentheses match up. They make one of the final 2 parentheses, and then the stuff on the outside, the x squared minus 1, made up the second set of parentheses. At this point, we're factored. So what we want to do now is solve each of the factors.
Why did you only bring down one of the x minus 4s?
Because if you think about it, these x minus 4s, if you consider this 2 different terms, x squared times x minus 4, and then the -1 times x minus 4, if you consider that just 2 terms, the greatest common factor of these 2 terms would be the x minus 4. So you're sort of factoring out that x minus 4 as a GCF. And then in the second parentheses, you're putting what's the remainder. So if you had an x squared, x minus 4, you factored out the x minus 4s, those cancel, and you're left with that x squared. And then the same thing here with the -1 times x minus 4. If you factor out that x minus 4, you're left with that -1. So it's almost like this x minus 4 right here is the greatest common factor of these 2 terms. Did that help on that?
Somewhat. I'm just gonna have to work a couple of them.
Oh yeah, and I got 2 of these that I'll do, and there's only 2 that you are going to have to do also. So let me ask you this. This is now factored, What multiplicities are on the outside of both of these parentheses?
1.
So these would both have a 1 by them. Now y'all check this out. Since this highest exponent up here was a 3 when I started, that tells me I need 3 zeros out of these two factors. So the highest exponent tells you how many zeros you should get. So let's find our zeros by setting both of these factors equal to 0. All right, so the first one, x minus 4 is 0. To solve it, I'm going to add 4. So my first 0 is a positive 4. Now for this one, since I got an x squared term and a number, I'm going to add the number to both sides. And I get x squared equals 1. Then we're going to take square roots. So the square root of x squared is an x. And y'all remember the square root of 1 is a plus or minus 1. So my 3 zeros would be 4, 1, and negative 1. So for our answer, they'll have the zeros are blank. Each zero has a multiplicity blank. All right, y'all, let me let one in real quick. Amy Houston. All righty, so the 3 zeros, well, we got them right here. We got a 4, a negative 1, and a positive 1. So that's my 3 zeros. And remember, the highest exponent tells you how many zeros you're going to get. So y'all, each of my zeros has a multiplicity of what?
Three.
Oh, now remember, that's just a degree. So 1, there you go. Because you got to look at when you got it factored here, what were those exponents we were putting out there? All right, y'all, let me see my chat here. Okay. All right, y'all, so that's going to be the trick. I'm going to give us another 4-term one. We're going to factor it, figure out our multiplicities, and then get them zeros, okay?
When you answer it on Math Lab, will it matter what order you put the zeros in?
No, they just want the 3 numbers. The only thing they're picky about is separating them with a comma.
Okay.
All right, same thing on number 10. Find the zeros. So find the zeros of the function and state the multiplicity of each. All right, y'all, so this time they're giving us f of x equals 6x to the 3rd minus x squared minus 294x plus 49. So let me make sure I got all my numbers right. 6, negative 1, negative 294, and 49. Woo, so they gave me a big one here. All right, so remember, we're going to factor by grouping again. So to factor by grouping, I'm going to form 2 groups. Each of these will have 2 terms each. And we're going to factor out the GCF of each group. So y'all, I ask y'all this. I got a 6x to the 3rd and a negative x squared. What is the GCF of these first two terms?
One.
X squared.
So I heard a 1, but at this point, the 1 ain't really helping me on these two. So what I would focus on is those variables.
X squared.
X squared. So they both have at least the X squared. And y'all, here's a trick. When you got variables that you're comparing, the GCF will always be the variable with the smallest exponent. Now, you had a 6x to the third. You factored out an x squared. That's going to leave a 6x minus. Well, let's think what's going to go here. I had an x squared. I factored out that x squared. So the only thing that's left, x squared divided by x squared, would be a 1. Now, second GCF, we said always had the same sign as this third term here. So since that's a negative 294, the next GCF will be negative. All right, y'all. So for this number 10, whatever this last number is, it'll divide into this first number. So that's how they got it set up. So that the GCF on the second set of numbers will be the 49. And y'all, guess what? 294 x's divided by 49 will leave you 6x. So remember, negative divided by negative made that a positive. Now, how about this? 49 divided by that negative 49 is going to make that a negative 1. So for number 10, whatever that last number is, and it's going to be fairly large like mine, but it will divide into this first number to give you what you needed here. Because remember, these parentheses got to match up at this point. And now remember, all this is still equal to 0. So y'all, I'm about to factor that into my last set of parentheses. So do y'all remember what I'm going to put in both of these parentheses? How about the first parenthesis?
6x minus 1.
So 6x minus 1, and my second parentheses. And y'all remember?
X squared minus 49.
Exactly, because you factored out that 6x minus 1. So what's left is that stuff on the outside, which is the x squared minus 49. So it's almost like your parentheses match up. The second parentheses always looks like the GCFs, okay? All righty, at this point, it's now factored. There's no exponents on the outside of these parentheses, so we treat it like they both have a 1 outside of them. Now remember, I got an x3 term here, so that 3 is going to tell me I'm getting 3 different zeros. So I'm going to set that 6x minus 1 equal to 0, and then the x squared minus 49 equal to 0. So you notice one of these will solve, and then the other one I'm going to do the square root stuff too, okay? So here we're going to add 1 first. We get 6x equals 1, and then divide both sides by 6. So that cancels, giving me my 1x equals 1 over 6. Second one, I got an x squared term and a number, so I'm going to move the number to the other side. I get x squared equals 49. Square root both sides. So then I get an x equal to what? A plus or minus 7. So my zeros are blank. Each has a multiplicity blank. So your 3 zeros are your 3 answers you got. You got me a 1, 6, and a 7, and a -7. And we said each of these has a multiplicity of, the exponent we had to write up here was a 1. All right, y'all. So that's the trick on factor by grouping. Get your 2 groups of terms put together, factor out the GCFs, make sure your parentheses match. The parentheses got to match so that you can go on to this step where you bring the parentheses out front. Everything else went into second parentheses. At that point, we were factored. And at that point, all we had to do was solve for the actual zeros down here. I won't lie, factor by grouping is sort of tricky. But some of y'all will see that if you have to take trigonometry or calculus, okay? All right, y'all. So for the last thing in this section, the multiplicity also tells me something else about these factors. So the multiplicity of a factor tells us whether the graph of the polynomial crosses the x-axis at that 0, or if it is tangent to the x-axis at that 0. So y'all, let me show you what we're talking about here. So if the multiplicity is even, if the multiplicity is even at a factor, then the graph is tangent at that 0. So then the graph is tangent to the x-axis at that 0. So y'all, let me show you what I'm talking about on that. So say I worked a problem and my 0 was 5, and say it was an x minus 5 squared or an x minus 5 to the 4th. If it was a even multiplicity, what it means to be tangent is the graph is going to come down, touch the x-axis, and then it shoots back up. So tangent means it just comes down and touches that x-axis and then heads back up. Okay, so this is what we call tangent, when it does not physically cross that x-axis. So what was our second choice? If the multiplicity is odd. So y'all, if the multiplicity is odd, then the graph crosses over the x-axis at that 0. So say I had me a graph. So let's say my 0 was over here at 2 or so. But if it had a exponent of 3, 5, 7, any odd number, what's going to happen is it's going to pass through the x-axis. It's going to cross right over it if the multiplicity is odd. So even multiplicities are tangent, odd multiplicities cross over the x-axis. So y'all, I'm just going to play with y'all just to give you more meaning. So I'm going to determine if the graph crosses the x-axis or is tangent at each 0. So say I had me a polynomial, p of x equals, oh, what I want, how about it? X plus 3 squared times x minus 4 to the third. So here's my polynomial. So the first 0, if I was to set x minus 3 equal to 0, I mean x plus 3 equal to 0. If we set x plus 3 equal to 0 and solve that, we subtract 3 from each side and we get x is a -3. The second 0, I would set x minus 4 equal to 0, add 4 to both sides, and I get x equals 4. So at the point -3, 0, because remember, 0, if you set it up as a point, will be -3, 0. So y'all, at this point, -3, 0, the graph, well, the question is it going to cross over or is it going to be tangent?
Which exponent do you choose to use? Like which equation?
So since this was -3, 0, that 0 came from the first factor, which was x plus 3 to the squared. And I'm looking at that exponent for the multiplicity. So that's an even multiplicity. So we said
Tangent.
it's going to be tangent. There you go. So at -3, 0, the graph is tangent to the x-axis. What about at the point? So there's my second 0, so that would be 4, 0. At this point, 4, 0, the graph is what? Is that graph tangent or is it going to be crossing right over it? And so I'm looking. Crosses over because that is an odd exponent. So at this point, the graph crosses the x-axis. All right, y'all. So they got 2 true and false coming out of these type questions. So let's see what we think. So y'all, let me get my camera set back up. So for these next example, determine whether the statement is true or false. All right, so number 11, we got if p of x equals x minus 7 to the 8th times x plus 6 to the 7th. Then the graph of the polynomial crosses the x-axis at the point 7, 0. True or false? So to cross that 7, 0, you got to look at which factor has a 0 of 7. Well, y'all, that had to be the first one, right? If you said x minus 7 equal to 0, you get a positive 7. So that's the point they're giving me, 7, 0. So true or false? Is it going to cross that x-axis at that point?
False.
It is definitely false, because that one has a multiplicity of 8, which is even. So since that's false, it's false because the exponent is even. And since it's even, the graph is actually tangent to the x-axis. Okay, so we said it was false because this was an even exponent and it don't cross it, it's actually tangent. All righty, good job, y'all. So let's try this number 12. This one has if p of x equals x minus 2 to the 9th times x plus 1 to the 4th, then the graph of the polynomial is tangent to the x-axis at the point -1, 0. So at this point, -1, 0, you got to determine which factor has that as a 0. What's its multiplicity? And find out whether this is tangent or if it crosses. So is it going to be true or false?
True.
It is definitely true, because that factor became a exponent of 4 is even. So the exponent of 4 is even. Thus the graph is tangent. To the x-axis. So for them last two, you're looking at which factor did the 0 come from that they're giving us, and then we're looking at those exponents, okay? So for this one, we had to look at the 4 because that -1 came from that factor of x plus 1. All right, y'all. So like I said, I only wanted to do one section today. So that was 8.1. Reason it took us a little longer is because we did the actual support first. Because I wanted y'all to learn about the different terms that we call a polynomial and what that degree was, okay? All righty, y'all. So I'm going to stop this share. So y'all, we're only doing 8.1 today. The main thing is get used to the zeros and those multiplicities, okay? And remember, zeros are the same as solutions, And to find zeros, we set the equation equal to 0. And those zeros are also equal to the x values of those x-intercepts, okay? So y'all, let me see. I'm going to stop our recording so that I can get it sent out in a little bit.